Hello everyone, this is the second video in the terminal course. In this video we will discuss the anatomy of shell commands and examine essential terminal commands for navigating the file system. By the end of this lesson we'll have a folder structure representing this course with a few files in each folder. Along the way I'll explain the details of the commands we use and the underlying concepts. First off, let me clean up the mess on the screen. You can do this by simply typing clear and pressing enter. You can also achieve this by pressing Command K on a Mac and Ctrl L on Linux systems. Next, I'll change the directory to my home directory by typing cd tilde. I could have also typed cd with no arguments, as it's an alias for changing the directory to your home directory. In Unix-like operating systems, each user is assigned a unique directory that serves as their personal workspace, commonly referred to as the home directory. This directory is the user's default landing spot upon logging into the system and acts as a central location for personal files, configurations, and other user-specific data. To take a look at the absolute path of your working directory, you can type pwd. The tilde character is a shorthand for the home directory. Thus, if you wanted to navigate to a folder named project in your home directory, you could simply type cd:/projects. Absolute paths always start from the root of the file system. These paths don't change over time and will always lead you to the same place. For instance, /users/artex/project begins at the root and leads directly to the projects folder inside Artex's home directory. Relative paths, on the other hand, are based on your current location. They don't originate from the root but from your current directory. So if you're already in /users/artex, you can navigate to its projects directory by typing cd:/projects. The dot represents your current directory, often used for executing files in the current location and rarely for navigating. But why? Because if you don't use the dot or the absolute path, then it's considered to be a relative path from your current directory. So you can simply use cd projects. Let's practice by moving up one level. To do this, we'll use the double dots that represent the parental directory. Type cd:// and you'll navigate up one directory level. To access the project directory again, you can simply type cd projects. Now you might be wondering how to view a list of all the folders and files in a directory. To do this, you can type ls, which stands for list. By default, the output appears alphabetically in a line, which might not always be convenient. Therefore, you'd commonly use this command with the -l flag, which provides output in the long format. In short, the ls-l command displays a detailed list of files and directories in the current directory, showing their permissions, number of links, owner, group, size, and the date and time they were last modified. There are quite a few things that we haven't discussed yet, and we'll get back to them in the next videos, but one particular thing I want to emphasize now is the fifth column, which is file size in bytes. It's not very convenient to think in bytes, so to make it more human-readable, we can use the -h flag, which stands for human-readable. Now it's clearer. So if we go back to our course folder and run the ls command, we won't see anything as the folder is empty. Here, I will create a directory for the first lesson with this command. What this command does is that it creates the directory and moves us into it all in one go. Now I would like to see what I have in the course directory. I could go one level up and run the ls command there, but I can simply pass the parent directory as an argument to the ls command and it will work. Now that we've gone through both arguments and flags for commands, I want to show you a metaphor that might help you understand the difference between an argument and a flag. Terminal commands can be described by the following structure: verb, adverb, noun, object. Essentially, the action, the manner of action, and the target of that action. In our prior example, the action, verb, was the ls command, or list. The manner, adverb, consisted of our flags, namely long format and human readable. Lastly, the target, noun or object, was the parent directory, signified by two dots. You can interpret the command as list everything in the long format and human readable within the parent directory. Alright, we have our folder. Let's create another one alongside lesson 1 and move into it. Can we do it from the same directory the way we did it with ls? Absolutely, and this showcases the power of relative paths. We can type mkdir /lesson2 and ncd:/lesson2. Notice how I use the backslash to escape the space. If you skip it, the terminal reads the 2 as a separate argument for the mkdir command. And while we're on the topic on mkdir, there's also the rmdir command, which deletes directories. But let's save that for later. If you take a look at the command we typed, you can see that you can combine two commands in one with a double ampersand. This ampersand symbol is a logical operator signifying AND. It's a neat trick that lets you run several commands in one sequence. However, there's a catch. The second command, the one after AND, will only run if the first completes successfully. To illustrate this, let's take a look at this example. Suppose I want to create another lesson 2 folder. Yeah, I know that it already exists, but imagine that I made a typo. And then switch over to the lesson 1 directory. When I run this, nothing happens and I remain in my current directory. This is because our first command in the sequence, mkdir, exited with a status of 1, which signifies failure. Because of this, the double ampersand didn't get to the cd command, so I remained in the same place. Well, you won't see the status, but you see the error in the terminal. Don't worry, we'll dive deeper into these exit codes when we explore shell scripting later on. Now that I'm in the lesson 2 folder, I want to create a text file. There are multiple ways to create a new file, but I want to show you 2 at the moment. When we simply want to create an empty file, we can use the touch command, touch text. If we list the current directory files with ls-lh, we'll see it's there, but its size is 0 bytes. Initially, this command wasn't designed solely for creating new files. Its purpose is broader. Look at the second last column of the list command output. It shows the date and time the file was last modified. Right now it says this, but if we run the same touch command again, it won't create another file or overwrite the current one, it will metaphorically touch it, meaning it will update the access and modification times of the file to the current time. Let's make sure that it doesn't actually overwrite the file. To do that, we'll need another file with content in it. Here's another way to create files. First, in the terminal, there's a command similar to console log or printf called echo. If we type echo text, it will print text on the screen. We can then send this string to a new file using the redirect output operator by typing echo text more than new file. Let's verify now that the file now exists with ls. Yes, it's here, and its size is 5 bytes. Now let's finally confirm that the touch command doesn't overwrite existing files. If we type touch new file, we'll see that the file remains at 5 bytes, but its modification time has updated to the current moment. Time for some cleanup. I only want new file in this folder, so I need to delete the text file. I can use the rm command for that, but there is a catch. This command is silent, making it potentially dangerous. However, we can make it friendlier by using the -i and -v flags. The I stands for interactive, which means it will request confirmation before trying to remove a file. And the V stands for verbose, indicating it'll display the removed items. Plus, a cool feature is that you can combine flags, though not all, by writing just one dash followed by the letters. Let's give it a shot. When I type rm-iv text, it waits for my confirmation. The possible answers are N to decline and Y to approve. I type Y and press enter, then I see the name of the removed files. To maintain a consistent structure for our course, I'd like to have the same new file in the lesson 1 folder as well. I can copy the file to that folder using the cp command. Just like the rm command, cp is also silent by default, so we'll use it with the I and V flags. This command will copy the new file and place it in the lesson 1 folder. If I accidentally run the same command again, it will prompt me to confirm if I wish to overwrite the file. I'll choose End because I don't want to, and it will notify me that the file wasn't overwritten. It's a good practice to use these flags. Otherwise, everything happens without any prompt. For a finishing touch, I'd like to rename the file in this directory to something more descriptive, like notes.txt. We can use the mv command for this. The mv command serves to move files or directories from one place to another or to rename them. It doubles as both a moving and renaming tool depending on how you use it. It might seem unusual for a single command to both move and rename files, but in the context of file systems, renaming a file is essentially moving it within the same directory while assigning it a different name. With this command, we'll rename the file. Let's clarify the change with ls to ensure everything's correct. To wrap up this command, let's move the file to the first lesson folder. The only difference in syntax will be with the second argument. Instead of giving the file a new name, we'll provide a relative or absolute path to the other folder. For example, another check with ls, and it confirms it's there. Now that we've established our course folder structure, there is just one more thing to demonstrate: how to clean up everything at once. I mentioned the rmdir command earlier in this video, and it won't help us remove the entire course directory since it's not empty. Instead, we can use the rm command with the powerful R flag, which stands for recursive. Currently, as we're in the lesson 2 directory, you might assume that we can execute the command from here. Let's try. As evident, this operation isn't possible. We'll need to navigate up 2 levels with cd and then run rm-r with the v and I flags to ensure that we don't inadvertently delete anything. When I press Y, you can observe that the rm command progresses recursively through the directory. You might be thinking, how can one possibly remember all those flags? Well, you don't have to. You can always brush upon the flags or other information about commands by checking the manual. For instance, if you type man rm, it'll pull up the manual for the rm command where you find all its flags and sometimes even examples. That's all for now. Thank you for watching and see you in the next video.